Let's take a look at the service delivery models in cloud computing. So there are these major service delivery models. You may have heard of these: software as a service, platform as a service, and infrastructure as a service. Right. So these are the three main ones. So what is software as a service? A software as a service provider offers software or application hosted in the cloud. So here, when we say software as a service, that means the service that's being provided is the software itself, the app itself, right? So for example, you have Salesforce.com. That is a customer relationship management system, right? So Salesforce.com, that's a big one. You can just think of any software that is provided as a service where you as the user just go and use the service, and you may pay or not pay, but it's usually a paid service. So for example, you have these one, Salesforce.com. So businesses use those to manage their customer relations. You have Workday. You have Workday, which is a human resource management system. So you can imagine work employers would be using this to manage their human resource side of business. And then you have apps like Google Apps, right? So this Google Apps, like for example, you use the storage, cloud storage. What is it? Google Drive. That is an example of software as a service, right? You are using a software, the Google Drive, that the company Google is providing to you as a service, right? Or you have what else? Gmail and so on. You have Remedy Force and so on. So you also have lots of timetabling, task management apps, right? Timetabling apps that you can easily go onto Google Play and you can download an app. You might have to pay every month, or you can pay annually, right? So you pay for the service, and the service that you get is just a software, right? It's an app. That is the service that you use. So that is something that would be familiar to us as users, right? Then we have platform as a service. So platform as a service, these are the cloud vendor provides the application platform, such as the middleware, the database, the messaging system, and so on. So this will be familiar for those of you who have tried making a hosted website. And that's usually what we call a platform as a service, where the provider gives you a platform, right? And then you build onto it. You build your application on it. So you are not the end user. Uh, in a typical case, you are not the end user. You will build a system on it that you might then give for as a service to other users, and then you would charge them, right? So yeah, if you look at this, software as a service, this is what you consume. Software as a service is for the consumers, right? For example, when you are the consumer of, let's say, Google Apps. Platform as a service, this is where you build, right? This is for building onto. So here you would make a website, perhaps. You will develop something that you would then probably give to others for use. Then we have infrastructure as a service. Cloud computing vendors provide infrastructure services as computers, storage devices, and routers to deploy your application. So so this is something like you can think of as, oh, the infrastructure, you can migrate to it. So you already have your system set up, and now you want to move to a new infrastructure, so you migrate to a new infrastructure. Right, we will look more closely at this, but I hope you can understand that these are the different levels, like how to view them. So software as a service means it's the services that you have available as just the apps. It's ready to use. It's for the consumer. You just consume it, like um, customer relation management systems, or ERP systems, or collaborative systems. Like you have a Stack, um, or you have other paid versions of cloud storage and so on, right? Or email. And then platform as a service means this is done halfway. So all you have to do is to start building onto it, but it's not ready to consume. You have to build on the platform. For infrastructure as a service, this is something you probably migrate to, because here you have to build everything from infrastructure upwards. You have to look into the security, you have to set up the networking, you have to set up the caching, you have to set up the system management configurations and so on. Okay, so these are the three major service delivery models. So there will be two things. You will see deployment models and service delivery models. Do not get these two things confused. Right now we are talking about delivery models, the models through which we would deliver the service. You could deliver your service as infrastructure or as platform or as software, right? So these are the service delivery models for delivering your service. Okay, let's look at infrastructure as a service a bit closely. So if you imagine this being the whole stack of what the users get to use at the end, what you have is right at the bottom, you have your physical environment, right? This is the electricity provided to the physical system, right? Physical machine. The physical machine uses the electricity. You have to provide the cooling system, right? The aircon and so on. The space, the actual physical space where this is set up. So all those things, the physical, the actual place where the machine is. Okay, so you have the machine, and you on top of that you need to set up the network so it can communicate, right? Just that bit, the physical machine with the network, maybe not, right? Just that part, the physical machine part. This is the service that is being sold. This is the infrastructure as a service, right? So this part is known as the infrastructure. It's the physical machines, the electricity that is used, the cooling systems and the space, physical space and all that. That is the infrastructure. And if someone is selling this and charging fees for it, so we call that the infrastructure is being sold as a service, right? The service sold is infrastructure. Then the person who buys this, not buys, the person who hires this service, like they would be paying a monthly fee, a yearly fee, or so on, right? So the consumer of this, the person who is the customer for this, who is using this service, will then have to set up these things on top of it to make it useful. What things will they have to set up? They will then, on top of the infrastructure, they will have the responsibility to set up the server operating system, right? Like you use your PCs. What are the operating systems that we know of? Like you guys use generally, we usually use Windows, right? Easily. It comes with Windows. We have Linux operating systems. There's the Mac, right? Um, so usually when it comes to servers, it's usually either Windows or Linux servers. Right. Anyway, so you have to then set up your operating system. You have to set up other platforms that are required to run your applications, and then you have user applications on top of that. Okay. So here, when we talk about infrastructure as a service, it's the physical machines and the systems that take care of the machines. Sometimes it includes the network as well. That is the service that's being offered. So we call it infrastructure as a service. Let's take a look at this scenario here. We have, what do we have? We have the cloud consumer who is, okay, who is using this cloud, and the cloud provider is providing the cloud. You have a physical server, right? This is the infrastructure. You have the physical server that is being offered as a service, right? And so you also have your virtual server. So let's see, infrastructure as a service, cloud service contract might look like this. The product is the virtual server, okay? And the specifications are, okay, the virtual server has 32 GB RAM, 4 GB local storage, Service level agreement says availability will be 99.5%. There's no failover, meaning they take care of failover. What would that mean? We looked at it in a previous slide. How do we take care of failover? You would have redundant instances of the virtual server that this service provider is offering. They probably have copies of this virtual server which is ready to use by this cloud consumer in case this virtual server goes down. That is part of their service level agreement. They're saying that we will have it available. Your service will be up 99.5% of the time. You will never face failover. Right? We are going to take care of failover situations. And the price is going to be 95 cents per hour, 5 cents per GB transferred out of cloud. Okay, so this is what the contract might look like. So what is the cloud consumer using? The virtual server. This is a platform, and this is the infrastructure that they are using. What will they have to set up on this? They will need to set up the operating system and everything up above that. All the systems, they will need to set it up themselves. It's a plain virtual server that they're getting, and they need to configure everything else. Okay, so that is a scenario of infrastructure as a service. Please make sure you understand what this whole concept. When they're being offered this service, the product is a virtual server. They're getting some RAM for processing, and they're getting some local storage. And the service level agreement says we will have it available 99.5% of the time. We'll take care of failover situations, and the price is going to be 95 cents per hour, and so on. So they may pay for this per year or per month, something like that. And also there's a charge for 5 cents per GB transferred out of the cloud. So infrastructure as a service is generally expected to comply with the following. Resources are distributed as a service. It allows for dynamic scaling, has a variable cost or utility pricing model, and generally includes multiple users on a single piece of hardware. So what that means is, okay, so if we say allows for dynamic scaling, variable cost, utility pricing model. Okay, utility pricing model, meaning, yeah, it's like this, similar to how we get charged for electricity. The more you use, the more you pay, right? So it's like per hour and per GB. Utility pricing model, that's what we mean. What else? Allows for dynamic scaling, generally includes multiple users on a single piece of hardware. So what the provider might have is they might have a physical server, and on this physical server they may be having many instances of virtual servers. So there's this virtual server consumed by this consumer. They may have hosted on the same physical server another virtual server which is used by another cloud consumer, and they can have like 3, 4, 5 many virtual servers that are running on the same physical server, right? So that's what it means. And it has allows for dynamic scaling. What is that talking about? So allowing for dynamic scaling means without having to pay like for long periods of time, like, okay, I want some extra CPU, or I want some extra RAM. Let's say this cloud consumer is getting this product, but then suddenly for just 1 week they want another 32 GB RAM. So dynamic scaling would be that if suddenly they want another 32 GB RAM on the same package, they can easily just get it and just pay that additional price. Or if they no longer need 32 GB, they only want 12 GB or 16 GB, they can easily reduce that, right? So that is dynamic scaling. It can be scaled on the go. So infrastructure as a service, it's generally expected that it would have these characteristics. So where infrastructure as a service may be considerable, so where demand is very volatile. Anytime there are significant spikes and troughs in terms of demand on the infrastructure. So in those cases, it's ideal that the consumer gets infrastructure as a service rather than platform or software as a service. Also, it is useful for new organizations without the capital to invest in hardware, right? So let's say it's a new startup. Instead of having to buy and pay thousands of dollars on physical machines, instead they can easily just buy these virtual servers and just access it through the internet, right? That would cost them much less than buying actual machines. Where the organization is growing rapidly and scaling hardware would be problematic. So similar to the previous point, rather than just buying more physical machines or larger machines, they can easily just get some virtual servers and expand on that. Where there is pressure on the organization to limit capital expenditure and to move to operating expenditure, right? So again, to fit the budget for specific line of business, example for trials or temporary infrastructural needs. Right? So these are situations where you should consider infrastructure as a service rather than platform or software as a service. So please make sure you understand the concept behind it so that it just makes sense when you ask the question of when would you consider infrastructure as a service, right? So when you are limited on budget, or when you are think of scenarios where you need to buy new machines and then you just think, oh, instead of buying new machines we would save money if we buy virtual servers instead. Where infrastructure as a service may not be considerable, so these are scenarios where you shouldn't really consider infrastructure as a service, and instead perhaps you should consider platform as a service, software as a service, or maybe buying your own physical machines and setting up your infrastructure yourself. So where are these two situations? So where regulatory compliance makes the offshoring or outsourcing of data storage and processing difficult. So what does this mean? So if you buy virtual server as your service, that means you are going to put your data and your system uh, physically somewhere else, most likely not in your own country, and it's probably going to be stored physically in some other country. And there are circumstances where you may have laws in your country or regulations in your country that forbid that, right? So for those situations, you will just need to set up your own infrastructure physically in your own country and work in that way. Another situation is where the highest levels of performance are required, and on-premise or dedicated hosted infrastructure has the capacity to meet the organization's needs. So in scenarios where on-premise or a dedicated hosted infrastructure is, obviously seems like the best option for your organization, that is when you should not consider infrastructure as a service. Um, Also, because infrastructure as a service, it's like it's still set up by someone else, and so it may not be the best setup for your organization. For example, let's say Mark Zuckerberg was starting off making a service such as Facebook, right? So it started off small. You would start off with one website and it doesn't need much infrastructure or anything like that. So you just get a platform as a service, right? Just a normal hosted website, and that is all you sign up for. And then eventually, if the service expands so much that it's now got millions of users, is it still wise for them to just have a hosted website that is actually physically stored somewhere else? No, it's at some point it had become much wiser for them to set up their own infrastructure, and so they did end up creating very large buildings that hold their machines, right? So it depends. So if highest levels of performance are required, then you may not want to get infrastructure as a service, and you may just want to make on-premise setup for yourself or your organization. Okay, so it's not that always infrastructure as a service or platform as a service or software as a service is required. Sometimes, depending on the situation, you may want to have on-premise or dedicated hosted infrastructure. Okay, let's see some benefits and drawbacks of infrastructure as a service. So benefits would be you have maximum control of application environment. Because why? Remember, the application environment is on quite up in the stack of things when it comes to the computing environment, right? Application environment is right on top, and at the bottom is your infrastructure. In between, you have things like network, and then you have the operating system, right? So if you want to have maximum control of your application, you would like to have control, right from the bottom, right from the infrastructure level. So you get infrastructure as a service. You have freedom of software selection because you are setting up everything yourself. Even the operating system you will set up yourself. Maximum flexibility in application topology. Potentially lowest cost option. Why? Because the provider is not doing a lot of work in setting up the environment for you. They don't have to spend hours and a lot of money in setting up the software, the operating system, and so on, right? You yourself, not you, but the consumer of IaaS has to sort out most of the things in there, in that stack. What are some drawbacks of infrastructure as a service? So it requires management of complete software architecture infrastructure, right? So that's what I was just mentioning. So it is potentially lowest cost. Why? Because you have to set up most of the things yourself, which is a drawback. Operational complexity of change control, right? So because you are setting up everything yourself, you need, the operational complexity is very high. Also, no hardware visibility deployment. So you are just getting the infrastructure as a service. You don't know what the actual physical machine is unless it's specified by the provider, but usually it's not. Okay, so you know what what virtual server you are getting. You don't really know what is the underlying physical machine. Let's take a look at platform as a service. So here you have the physical environment already set up for you. The network is set up. The server operating system is installed, and you have other platforms that are required for applications. This is also set up. Okay, and this is the bundle that you get as the service. So you don't need to worry about setting up operating system or setting up the network. Okay, all you need to worry about is making the application, which would then also have the user applications. Okay, so that is platform as a service compared to infrastructure as a service, which was just this part, the physical environment and the network. Okay, let's look at a scenario of platform as a service. Okay, the ready-made environment is the thing that is the service here, right? The ready-made environment having some usability is very easy here compared to infrastructure as a service. You have your database system set up, and operating system and all is already set up. The cloud consumer gets to use the virtual server. So just think of an example like hosting a website, right? So here you would have a contract that looks something like, okay, platform as a service, cloud service contract. The product is application server plus a database management system platforms. And its service level agreement is availability 99.5% availability. You will have auto scaling available, and the price is 45 cents per hour. Um, and you have about 500,000 requests, right? So that is what you have available. I hope you can see the difference between this and infrastructure as a service. Infrastructure as a service, you have the you don't have the operating system installed, right? You don't have database management system installed. You don't have any. There's no software installed on it. You have to set all these up yourself. But in platform as a service, you have this set up already, and then you will just go on and build your application on it. The characteristics of platform as a service. So here, services to develop, test, deploy, host, and maintain applications in the same integrated development environment. Web-based user interface creation tools help to create, modify, test, and deploy different user interface scenarios. Multi-tenant architecture, where multiple concurrent users utilize the same development application. Built-in scalability of deployment software, including load balancing and failover, integration with web services and databases via common standards, support for development team collaboration. Some platform as service solutions include project planning and communication tools as well, tools to handle billing and subscription management as well. Okay, so the easiest way to imagine this setup platform as a service is when you try to make a software or you try to make a website and you have some kind of service or provided on your website that users can use, they can sign up for, they can subscribe to, and so on. But it's available as a website, and you have gotten yourself a platform as a service. You as the provider would have gotten a platform as a service. For example, some service to host your website, right? So there you will get space to develop your website and the services that you want to run on the website. You get to test it, you get to deploy it, you get to host and maintain the applications that you make on the website. Right, so it's a web-based user interface creation tools will help you to create, modify, test, and deploy different services that you want to create. Also, this kind of service, the platform as a service, it is multi-tenant architecture, meaning you are probably not the only person, not the only customer using that platform as a service. It would have been virtualized, and so you get one partition, you get one set of resources, but on the same machine, physical machine and physical, the infrastructure, there might be other people who are building websites and trying to make their services and so on, right? So multi-tenant architecture is there. Built-in scalability. So if you need to carry out load balancing and you need to look into your failover, then all of this is provided in there already by the platform as a service provider. Um, and you can easily integrate with other services. The platform as a service is provided. It will come with other tools, many other tools that you can integrate. Also, some of them will allow you to have team members collaborate, right, to help you build your website and the services. They will allow for many team members to log on and help in creating and managing of the website or the services that you are creating on that platform. So when should you consider a platform as a service? Platform as a service, it is especially useful. Platform as a service is useful where developers wish to automate testing and deployment services. The popularity of agile software development, a group of software development methodologies based on iterative and incremental development. What are the benefits and drawbacks of platform as a service? So benefits would be you have higher developer productivity, you have less infrastructure management because the platform as a service provider is going to set up all the infrastructure for you. You have integration with the platform services as well. So those are the benefits. What are the drawbacks of platform as a service? You have something called vendor locked in, meaning it's usually the case that if um, you will be stuck with that vendor because it is dependent on the infrastructure and the platform that they have provided you with. So they have their own setup, and if you after some time want to move your service from their platform, um, it will probably not work on another vendor's, whatever they are offering you. So you will be logged in with that particular vendor. Application evolution at speed of vendor. So because it is the vendor who is looking after their infrastructure, so they are going to control the speed of their updates, right? So if they update at all, or do they keep the old structure, the old system that they have, or do they update and keep upgrading the system, that will affect your application as well. So if you are stuck with a vendor who is slow at evolving and slow at growing and upgrading, your applications that you are making will also be, evolving slowly. Limits to application functionality, right? So you will be limited. You will have the same constraints that your vendor is constrained by, right? If their machines, if the infrastructure is only allowing so much, you can only use so much. And if there's something more that you want to do, but your vendor does not provide that, then you will be stuck with this earlier drawback that I mentioned, vendor locked in. That is one of the drawbacks, right? You cannot move to another vendor, and unless you want. The the underlying point of all these drawbacks is that you, as platform as a service that you are getting, you can't have much control because your platform that you are using has infrastructure that is controlled by somebody else, the vendor, and you don't have much control, which is a very good advantage if you are getting infrastructure as a service. That's where you have a lot of control because you can set up any way that you like. Let's look at software as a service now. So what are the parts or the components that are available in this service? If you buy or if you get a software as a service, right, you get the physical environment, like everything that's in the infrastructure. So the physical environment with a network, we've seen that this is what we get as infrastructure. Then on top of that, you also get the platform setup already, right? So you have the server operating system and any other platforms required, and some system applications that manage that platform, right? So you get all of that in this service, right? And all you need to do is just use the applications, right? So this is what you get as software as a service. How would this look, and what would a software as a service cloud service contract might look like? It would be like this, right? You are a cloud service consumer. They they hire or use a cloud service that is in the cloud, and the contract looks like this. You have a service level agreement where saying that response time will be 0.5 milliseconds. The price would be, let's say, 5 cents per 100 requests. Right, so this is an example or a scenario, a possible scenario of cloud software as a service. So what are the characteristics? Software as a service that is employed over the internet, right? A software that is deployed over the internet. That's what we are focusing on, right? SaaS. Web access to commercial software. Software is managed from a central location. Software delivered in a one-to-many model. So there's one software that is the service, right? And many users or many consumers use this software that is the service, right? So it's a one-to-many model. Users are not required to handle software upgrades and patches, right? So they just use it. They're not required to look into the software upgrades and patches. Application programming interfaces or APIs allow for integration between different pieces of software. Where would this not be considerable? So applications where extremely fast processing of real-time data is required, we do not recommend that you use software as a service. It's better off that you go and invest into the platform or infrastructure as a service and build by yourself. That will allow for fast processing. Software as a service is not ideal if you want fast processing of real-time data. Another one, applications where legislation or other regulation does not permit data being hosted externally, right? So again, just like platform as a service, this comes into play. Applications where an existing on-premise solution fulfills all the organization's needs, right? So if there is existing on-premise solution for your organization, there's no need to go and invest in a software as a service because you can just build on to your existing on-premise machines, right? So these are the three reasons why you may not want to consider software as a service. What are the benefits? The benefits are there's no need for on-premise software, subscription based payment model, and automatic upgrades, right? You don't have to worry about fixing bugs or upgrading. What are some drawbacks? You have forced upgrades at vendors pace, right? So it all depends on the vendor when they want to upgrade, and you just have to go with it. Application functionality and extensibility limits, right? So because you are not making the software as a service, you are just using it. The vendor is the one making it, so they control the functionalities, the different features, um, and all the other extensibility limits. Such services, they usually have like a suggestion area, right, where consumers can submit their suggestions about what features would be ideal and so on, and then they get the developers of the software as a service. The developers look into those one by one. Data integration, availability, and ownership, right? So this can be of concern because you will be using it, you will be uploading your data, and its availability and who owns it and who owns your data once it's on it. That those things are of concern because the vendor is going to be in control of all this. A simple layered view of this. So here, a simple layered view of an architecture comprised of infrastructure as a service, right, which is down here, and platform as a service, which is this layer here, and software as a service, cloud service implementations. Okay, so these are shown here. So right down below, you have the actual physical server, and this could be given to consumers as IaaS, infrastructure as a service, by creating virtual versions of the physical server, right? And then you can have consumers who who are buying this or not buying, who are the consumers of this infrastructure as a service. And what do they do? Perhaps they can build a platform. They can set up the platform with an operating system and so on. Right? They can set that up and offer that as a service. Right? And then someone else can come along and consume that platform, and on that platform create a software. Right? They can create a software, and that software can then be given as a service for our cloud consumers, for other cloud consumers. So there are various levels, right? Three levels that we see here, three major levels that we see here, right? There could be cloud consumers out here who are consuming cloud service A, right, which is run on a ready-made environment A, right, which is running on virtual server A. Or you could have cloud consumers who are consuming cloud service C, which is a service that is provided as a software as a service, right? and it is hosted on this platform, right? A ready-made environment C, right? Which is then running on a virtual server B, which is running on the physical server A. So the consumer could be using either this, a customer for this software as a service, or this platform as a service, or this infrastructure as a service. And you have room for picking whatever level you want to work at. And we looked at which uh, situations call for which level. Software service applications are designed for end users, right? Delivered over the web. So things like what software can you think of? Customer relation management systems like Salesforce or Dropbox. This is for cloud storage. You have Google Apps, right? So Gmail, email, Yahoo Mail, or Google Calendar. So many. So pretty much anything you can get from Google Play, like the Play Store apps that you download, and other apps that you use on your desktop as well. So these are all software as a service. Then below that, you have platform as a service. So this is this set of tools and services designed to make coding and deploying those applications quick and efficient. Right. So this is not the end users who are going to look for platform as a service and pay for it. Right. Normal end users, they use software as a service. They are customers to software as a service. Platform as a service, it is for the developers, software developers, right, who do the coding and deploy the applications, right? So for this, you have things like Windows Azure for um, yeah, you have Windows Azure, you have Google App Engine, um, you have Force.com, and there are many others, AWS as well. And then you have infrastructure as a service. It is the hardware and software that powers it all. So servers, storage, networks, operating systems, everything. Right. So for this, we have a very big um, provider of this. It's Amazon Web Services. So from here, you can get yourself infrastructure as a service. You also have Rackspace and others. Now, controlled versus structured cloud services. Let's take a look. So more structured and less structured. Okay. uh, and you will see that control and structure, how structured it is, um, they are structuredness and control, these are complementary, right? So as you get less structure in the service that you are getting, you get more control. What does that mean? um, that means if you buy something that is like infrastructure level, you have more control, you have a lot of control, because you can set it up as you like. um, but as you go for more structure or something that is already set up for you, you have less control over it. You are stuck with the vendor, everything that the vendor does, even the features, the upgrades, the security, all of it, it's up to the vendor, and you have less control. So when you have more structure, you have less control. There are some other cloud service delivery models, which are not very popular, but they're like hybrids or something. Yeah. So let's see. There's communication as a service. So that's CaaS. Communication as a service is a collection of different vendor services that facilitate business communication. So types of communication as a service include voice over internet protocol or VoIP, right? So, or internet telephone solutions, and video conferencing services. So things like Zoom, Skype, right? And there are others. So that's communication as a service. Then you have monitoring as a service, or MAAS. It is a framework that facilitates the deployment of monitoring functionalities for various other services and applications within the cloud. State monitoring is very powerful because notifications now come in almost every form, from emails and text messages to various social media alerts like a tweet or a status update on Facebook. So example of this would be the MySQL Enterprise Monitor, or this monitor for Windows or Cacti, etc. Right? So there are many others. So these are monitoring as a service. Let's see the deployment models that are available in cloud computing. So we've looked at cloud delivery models, right? The different models that we use to deliver the service. Okay, that's what we looked at before. Platform as a service, infrastructure as a service, software as a service, right? Those are delivery models, models for delivering the service. Now we're looking at the models that are used to deploy the service. Okay, so that's these two are different things. Earlier we discussed delivery models. Now we are looking at the models used to deploy your cloud computing, your cloud service. Okay, so the different models for deploying your cloud services, right? So we have the private deployment model and public. And then we also have in between the hybrid deployment models. Okay. Now, a private cloud might look something like this. It is locked from the outside, and the nodes within the cloud can use the cloud services, and it is not accessible from outside the cloud. So that is a private cloud. Whereas a public cloud looks something like this. You have everything in the public space. Every everybody, every node can have access to this public cloud, the services that are offered on this public cloud. It is not hidden from anyone, or it's not locked from anyone. Okay, so you have your public cloud, you have consumer A, customer A, B, C. You have different parts of the cloud, but it's all public. Okay, and then you have the hybrid cloud, which is a combination of those two. Okay, so let's look at private, public, dedicated, and shared cloud. So here we have a matrix. We have private. So down here, things are more private, and here things are more public. Here we have dedicated infrastructure, and here we have shared infrastructure. Okay, so when you are private and you have a dedicated infrastructure, what does that mean? That sounds like an organization that has its own infrastructure, right? And it is using that infrastructure only to run its internal private cloud. Okay, so this sounds typical of like organizations, businesses, and so on. If the organization is big enough, um, if you extend that to being public but dedicated infrastructure, but it's a public cloud, you have a virtual private cloud. Okay, then if you are staying private but you have shared infrastructure, as in it's not dedicated infrastructure, it is shared but it's private, you have an external private cloud, meaning you have a private cloud but it is not running on your dedicated infrastructure, it is running on shared infrastructure. Okay, and then you have the public cloud. This is where it is open to the public, it is accessible by public, and it is run on shared infrastructure, right? So that is called public cloud. So there are these, you could think of like scales, right? This is the most private, and your own machines, and then fanning out. If you have your own machines, but it's a public cloud, you have a virtual private cloud. Or if you have if it's a private cloud but it is running on shared infrastructure, then it is external private cloud. Or if it's public and it is running on shared infrastructure, it is then public cloud. Okay, so the most obvious two are these two: the internal private cloud, where you have your dedicated infrastructure, your own machines. The organization has its own machines where it's running its own private cloud. And then the opposite is the public cloud where the machines are not owned by anyone specific. The whole infrastructure is shared and the cloud is accessible to everyone. Okay. Now, public cloud versus private cloud. Public cloud is publicly shared virtualized resources, right? So the resources that are found on the public cloud, these are virtualized resources, meaning it's not the specific machine that you get. Everything is likely virtualized. The We will look at virtualization in a chapter and things will make more sense. But it's like if you buy or if you consume and pay for a server, the server is not an actual physical machine. It could be a virtual. It's likely a virtual version, and there are many virtual versions that multiple tenants are using on the same physical server. It supports multiple customers, right? So that's the characteristic of public cloud. It supports multiple customers. Also, it supports connectivity over the internet, and it is suited for less confidential information. Okay, in contrast to private cloud, where you have privately shared virtualized resources, you have cluster of dedicated customers, connectivity over the internet, fiber and private network, right? So it can either be connected via the internet or it could be like a physical wired network. It's suited for secured confidential information and core systems. Okay, so for example, perhaps within a hospital, if it's a very large hospital, would they want to be having all their systems from one building to another building and so on? Is it ideal for them to be using the public cloud? No, it is more ideal that they have a private cloud setup. Finally, let's see the key challenges when it comes to cloud computing. We'll just do an overview because we will discuss the challenges in more detail as we go on in the into the course this semester, right? So key challenges, just basically we have the skinny straw problem. So this is talking about how having think of an example. Let's say you need storage, right? So if you have a hard drive, a physical hard drive with yourself, physically with you, and then you just move your data from your PC into your hard drive for storage, for keeping, right? Compare that to trying to upload it to your cloud storage, let's say Google Drive. If it's a lot of data, it's going to take a long time to upload everything, right? Because you have these skinny straw issues, like you have low bandwidth, you're connecting to the cloud, right? You're connecting to another physical thing, another physical machine somewhere else, right? So you have high latency issues, large data sets that take long, it's expensive to fix. um, Partial remedies are available, right? But you do have this problem. If it's a cloud service that you are working with, you really have to consider how much data you are putting up and downloading, and also your increase in cost. Then you have the app integration challenge, because you will need to integrate all the services that you're using, right? Using APIs and so on, and it gets very complex when you try to make these different services communicate with each other. Then you have the software licensing challenge, right? Especially because you have things like where something is physically um, compared to virtually using something. So your data is physically going to be stored somewhere. So all these issues about software licensing comes into play. Also, the biggest one is security, right? So security is a big part, and we will look at it closely later in the semester. Okay, so that wraps up our session for week 2. We looked at cloud-like services, right? Services that are there, technology that's there, which looks like cloud, like virtualization, like grid computing, and so on, right? But they are not exactly cloud computing. They are cloud-like services. And then we looked at definition of cloud computing, which is something that is not very defined and fixed. And we will work on our definition as we go on learning more about cloud computing. Then we looked at the cloud computing models and characteristics and the cloud computing roles. There were 7 main ones that we looked at. Cloud computing service delivery models and the deployment models as well. So hopefully you remember the difference between these. The delivery models, these are the software as a service, platform as a service, infrastructure as a service. And deployment models are how they're being deployed. How is the cloud deployed? Private, hybrid, or public? Okay. And then the key challenges. Okay, so that wraps it up.